Hello everyone, welcome to this video. In this video, we are going to learn about ARD regression using OpenMathAI. So, let's get started. What is ARD? Automatic, relevance, determination. Regression is a supervised machine learning algorithm used to predict a continuous numerical value, just like linear regression. However, unlike linear regression, ARD regression is specifically designed to automatically determine which input features are important and which are irrelevant. It is a Bayesian regression algorithm that assigns an individual regularization parameter to every feature, allowing the model to reduce the influence of unimportant features while retaining the most useful ones. ARD regression starts by considering all the input features and estimating their importance during training. Instead of applying the same amount of regularization to every feature, it gives each feature its own regularization parameter. As a result, the model automatically performs feature selection while building the regression model, reducing overfitting and improving prediction accuracy. Imagine you want to predict the price of a house based on features such as house size, distance from the city, number of bedrooms, house size, bedrooms, and strongly influence the house price. However, the distance has almost no effect on the selling price. Instead of treating every feature equally, ARD regression automatically recognizes that distance is not an important feature and shrinks its coefficient to nearly zero, while keeping the important features active in the model. As a result, ARD regression can produce accurate predictions even when the dataset contains many irrelevant or unnecessary input features, making it particularly useful for high-dimensional datasets where manual feature selection is difficult. We will use this dataset for the ARD regression model, so let's get started. Open OpenMathAI. In this demonstration, we use the house price prediction using ARD regression model. Click Create New Project. Enter the project name as House Price. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There is also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There is one more feature, Signal Diagnostics. There is 3 columns. First one is column. It tells which features are in the dataset like inputs and outputs name. Second one is VI. It tells how much correlation the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the ARD regression model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also the another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95, accuracy almost equal to 95%. Click Fit to Window, you will see three types. Fit to Window, comfortable, compact. Then the clear history if you click that it will clear the history before its trained model. Another is deselect and select all trained model for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. Answer C. FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these format and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.